Let's talk about graphing inequalities. So look at the inequality y is greater than or equal to negative 1/2 x plus 3. We can see that inequality symbol there is greater than or equal to. So this is really the combination of two different mathematical statements. It's y equals negative 1/2 x plus 3, and it's also y is greater than negative 1/2 x plus 3. So really, when we're graphing y is greater than or equal to negative 1/2 x plus 3, we are graphing both the equation and the greater than inequality. So let's start with the one that we're most familiar with. We know how to graph y equals negative 1/2 x plus 3. So we're going to find the y-intercept at 3, and then our slope is down 1, right 2. And we can make as many points as we want. We can even go the opposite direction, up 1, left 2. But we can see that line being created there. And let's go ahead and connect those points with a straight line. That way we get every single point. We can throw some arrows on the end to say that we know this line continues forever in both directions. So we've gone ahead, we have graphed the actual equation y equals negative 1/2 x plus 3. How about the inequality? The inequality is a little bit different. Think of all the different points that are actually solutions of this inequality. So we're looking at any x value that when you multiply it by negative 1/2 and add 3, it is less than the y value, or the y value is greater than that value over there. So let's jump down here. It says give 3 solutions to the inequality. And again, we're talking about this inequality here. And let's do that. Let's actually just kind of make a table of values. And let's walk through this. You can pick any input value. Let's say that I pick, for instance, 2. If I plug 2 into my inequality, we would have y is greater than negative 1/2 times 2 plus 3. Well, negative 1/2 times 2 is negative 1, plus 3 is 2. We're really getting that y is greater than 2. So for my y over here, it's not just one value, it's y can be greater than 2. It's all of the y's bigger than 2. So for instance, I could say the point 2, well, a y bigger than 2 is 4. Or the point 2, 7. I couldn't say the point 2, 1 because 1 isn't bigger than 2. So picture where those points are. We have 2, 4 would be here, 2, 7 would be here. Let's find more. What if my x value was 6? Well, if I plug that in, we'd have y is greater than negative 1/2 times 6 plus 3. Well, negative 1/2 times 6 is negative 3, and negative 3 plus 3 is 0. So y is greater than 0. So any y greater than 0 creates a point that's a solution to this inequality. So for example, if I had the point 6, 3, because 3 is greater than 0, well, that point is up here. So all of these points are points that are above the line. In fact, any point that I pick above the line is going to work in this inequality. For example, if I pick the point 0, 8. Well, if I plug 0, 8 in for the y is greater than negative 1/2 x plus 3, just to show you, I plug 8 in for y. 8 is greater than, well, negative 1/2 times 0 plus 3, that's 0 plus 3, and 8 is greater than 3. It is a solution. So any point above this line ends up being a solution. And that's really what happens when you graph an inequality that's greater than or equal to. The equal to part creates the line, and then the greater than part shades above or below that line, everything above or below that line. So every point above that line is actually a solution. So now this is the completed inequality graph. There's a line that shows the equal to part, and then the shading shows the inequality part. So what would be different if instead of it being y is greater than or equal to negative 1/2 x plus 3, what if it was just y is greater than negative 1/2 x plus 3? Well, now the equal to part that we found up here, this would essentially be gone. And so these points along this line aren't going to be allowed in the solution set anymore. So what's going to change is instead of using a solid line, we're going to use a dashed line when we would graph that. So really it would look something like, and I'll just kind of sketch it down here. It would look something like this, where you'd have a dotted line or a dashed line, and then you would shade everything above that. And that just shows the person who's looking at your graph that all the points above the dotted line are solutions, but that dotted line does not contain any solutions. So really that brings up an important thing here, the difference between when we use a solid line and a dashed line. So if we're looking at graphing an inequality, any time that the inequality uses the greater than or equal to sign or the less than or equal to sign, because of that equal to, that means that all the points on the line are actually solutions, so you want to graph it with a solid line. Whereas if you just are using the greater than or less than symbols, there's no equal to part, and so you don't want that line to be solid, you want it to be dashed. And that's usually the first thing I look at when I'm trying to graph an inequality, is decide whether or not I need a solid or a dashed line. So let's look at the two linear examples in this video. In the next video, you can look at quadratic examples, and then we'll also look at examples of when you look at a graph, how can you write the inequality? So number 3 on your paper, this is actually point slope. Do you guys remember? Whoops, point slope. Judging by the name, it gives you a point and it gives you a slope. So looking at this, the point that we get from this equation, remember it's always the opposite of what you see happening to x and y. So x plus 5 means the point will have a negative 5 for the x coordinate, and y minus 6 means positive 6 will be the y coordinate. So we can graph negative 5, 6, and then our slope we have is negative 7, or negative 7 over 1. So we're going to go down 1, 2, 3, 4, 5, 6, 7, and write 1. And we can do that again. 1, 2, 3, 4, 5, 6, 7, and write 1. So now the question is, should we connect this with a solid or a dotted or dashed line? This includes the equal to sign. So because it's greater than or equal to, that equal to part says that we should connect with a solid line. So let me pick up my line tool and go ahead and connect these points with a solid line. Again, we can put arrows on the end that say this continues forever in both directions. So now we need to decide what side of the line are we going to shade? Are we going to shade this side over here, or are we going to shade this side over here? And really what we're asking is, can I find a point either on this side or on this side that's actually a solution to the inequality? So if I want, I could just pick any point on either side of the line, test it. If it works, then I want to shade where that point was. And if it doesn't work, then I want to shade on the other side. So pick any point to test. And I'll give you a hint. If you can, pick 0, 0, because anytime you plug in 0, 0, that helps things to eliminate, and it makes the inequality a little bit easier to solve. So since 0, 0, the origin is not on the line, I'm allowed to use it as a test point. So I'm going to plug in 0 for y, so we would have 0 minus 6. And we're going to write down the greater than or equal to. We're testing if this is a true statement. Is the left side greater than or equal to negative 7 times, we're going to plug 0 in for x, plus 5. Well, over here, 0 minus 6 is negative 6. We're testing, is negative 6 greater than or equal to negative 7 times 0 plus 5? 0 plus 5 is 5. 5 times negative 7 is negative 35. So is negative 6 greater than or equal to negative 35? Yes, which means the point 0, 0 is a solution, and it lives on the side with all other solutions. So that means I'm going to shade over here to show that every point on this side is a solution. If it hadn't worked, then we would just be testing, or we would just be shading on the other side of the line. So an example of a solution, you could write 0, 0, or you could write down any point over here on the right side of the line. We're going to do one more in this video. Why don't you pause the video and see if you can figure it out on your own, and then come back and check with me. But this is in slope-intercept form. So we know that our y-intercept is negative 2, and our slope is 3/5. So we're going to start at negative 2, and we go up 1, 2, 3, and right 5. We can do that again, up 1, 2, 3, and right 5. We can go the other way, down 1, 2, 3, left 5, down 1, 2, 3, left 5. So how should we connect these points? Well, we have just the greater than symbol, not the equal to. So the only way that the points on this line could actually work in my inequality is if we had the equal to line or equal to sign there. So we're actually going to connect this with a dashed line. So let me choose, we want our line to be dashed. And we can connect all of these points with that dotted line. And again, we can put our arrows on the end to say it continues. But this just shows these points kind of help make that border from where we shade to where we don't, but these points can't actually work in the inequality, right? If I plugged in the point 0, -2, just to kind of show you what I mean, 0, -2 is on that line, but if I plug that in, 3/5 times 0 minus 2 is greater than y, which is -2. Well, 3/5 times 0 is 0, minus 2 is -2. So we have -2 is greater than -2, and that's not true. They're equal to each other, but one's not greater than the other. So 0, -2 is not a solution. That's why we have that dashed line. So now we want to see where to shade. So again, we're going to pick a test point, and you can pick any point that you want. My advice, pick the origin if it's not on the line, and in this case it's not, so we're going to plug in 0, 0. So 3/5 times x minus 2 is greater than y, and in x and y we put the zeros. 3/5 times 0 is 0, minus 2 is -2. Is -2 greater than 0? No, which means 0, 0 is not a solution. So we don't want to shade on this side, instead we want to shade over here on this side. So that means if I'm going to give an example of a solution, I need to pick a point from over here where I shaded. For example, like the point 5, -2. And if you want to confirm that you shaded in the correct place, I would suggest taking that and plugging it in. So 5, -2 is supposed to be a solution. We can check that by saying, okay, 3/5 times 5 minus 2 should be greater than -2. 3/5 times 5 is going to be 3. 3 minus 2 is 1, and 1 is greater than -2, so we know that that solution works. So go ahead, take some time, take a look at the back of your worksheet, see if you can figure out, we've got quadratics coming up next, so try to graph those and take a look at the next video.